So today's lesson on 3.4 is called linear programming, which is basically a fancy word about dealing with systems of equations and inequalities. So a couple of things that we're going to talk about with these systems is we are going to talk about maximum and minimum values. These are when maximum and minimum values. We want to know when the values of the function are at their highest or their lowest. So these is what you would use in business models and medical drug, the dosing for drugs, things like that, real application type problems. So first of all, we're going to go ahead and graph these right away, and then we're going to name the coordinates of the vertices. So we're going to go ahead and graph these three right here, just like we did in 3.3. So we have x is less than negative 5, and that, remember, is a vertical line. And so if we go over to 5, that happens to be a vertical line right here, and it's solid because it's less than or equal to. And if we think about where are the x's less than that happens in this direction. So that one was fairly simple to graph. This is a horizontal line. Y is less than 4, less than or equal to, so I have another solid line less than or equal to 4, and everything below that. So I'm starting to see a bounded region show up. Now this last equation is not in slope-intercept form, so I need to subtract x from both sides. Y is greater than or equal to negative x plus 2. So my y-intercept is at 2, and my slope is negative 1 over 1. And since this is also a less than or equal to, I have a solid line that's going to cut like this. Now, I need to test if I'm shading above this or below this. My guess is, since I'm looking for a region, it might be above, but I don't know for sure. So I'm going to go ahead and test with 0, 0. I'm going to go to my original. Is 0 plus 0 greater than or equal to 2? Is 0 greater than or equal to 2? That's false. So I'm actually looking at the region above. So messy though this is, the region I'm clearly looking at, where all three are represented, is this triangle right here. So the first says name the coordinates. So this is a lot like what we did in 3.3. So our coordinates are right here at negative 2, 4, right here at 5, 4, and right here at 5, negative 3. So that's the coordinates. So negative 2, 4, 5, 4, and 5, negative 3. Now, to find the maximum and minimum values, we are going of this function. Okay, so we are going to test these three values because those are key points, because they kind of mark the ends and the tops and the bottoms. So we're going to put all three of those points into that function and see where our values are the greatest and the least. And so we are looking at something like, to find max and the min, use the vertices in the function and evaluate. So if you remember, the function they're asking us is f of x is equal to 3x minus 2y. So if we test our first point of negative 2, 4, that's my inputs. What is our f of x value going to be? Well, if I have 3 times negative 2 minus 2 times 4, so I just did a substitution right here and right here of my key points and my variables, because those represent x's and y's, then what I get out is negative 6 minus 8, which is negative 14. That's one value. So then I'm going to test my next value. And my next value is 5, 4. I'm going to repeat with that substitution. 3 times 5 minus 2 times 4. So I have 15 minus 8, which is 7. And then I'll test with my final vertice value, because I had a triangle, 5, negative 3. So 3 times 5 minus 2 times negative 3 is equal to 15 plus 6, which is 21. Once you have those three values, then it's pretty clear to see the maximum of this function occurs right here at 5, negative 3, because that brings out the highest value. The minimum occurs right there at 5, 4, because that's the lowest. Oops, I take that back. It takes place right there at, gotta be careful of those negatives, takes place at negative 2, 4, the negative value. That one is not. So be sure to look at your values carefully. If we're going to graph the following system of inequalities, we're going to do the same thing. We're going to name the vertices, and then we're going to test and see where the max and the min are again. So we have to start with, as always, slope-intercept form. 2y is less than or equal to x plus 2. Y is less than or equal to 1/2 x plus 1. That should be getting to be a very simple standard procedure for us to go ahead and graph very easily. And this is less than or equal to, so I have a solid line. I'm going to use 0, 0 as my test point. And is negative 0 plus 2 times 0, is that less than or equal to 2? Is 0 less than or equal to 2? That's a true statement. So everything below this is going to be shaded. And if you want to go ahead and do a slightly less invasive mark like I just did, that's perfectly fine. Let's solve this one for y. Subtract x from both sides, divide by negative 2. Don't forget to flip your sign. And so I have negative 2. I have a slope of positive 1/2. And so I have a line less than or equal to, greater than or equal to, that is solid. If I go ahead and check my test point, is 0 minus 2 times 0 less than or equal to 4? 0 is less than or equal to 4. That's true. So that means I'm shading everything up. So even though I have parallel lines here, I would have a solution set. Now I need to figure out where this last line is going to cut through. Y-intercept form, very simple subtracting of x from both sides. Y-intercept is at negative 2, up 1, left 1, down 1, left 1, greater than or equal to a solid line. Pick up my test point. 0 plus 0, is that greater than negative 2? 0 is greater than negative 2, so that is true. So I'm shading everything on this side. And so my overlapping region, where everything is true, is this area right in here. Now one of the interesting things is this is going out to infinity. There's no maximum value this can occur because it is going to go to infinity. Okay, but I do have a couple of key vertices that I need to test here for my minimum. Okay, so right now I know there is no maximum. This thing will grow unbounded for forever. The minimum, though, I need to test the points of my corner vertices here are at -2, 0, and at 0, -2. So I'm going to go ahead and put those into this function right there. So there's my inputs of x, y. My f of x output is using this formula. So when I put -2, 0 in, I have 2 times -2 plus 3 times 0. So that equals -4. And when I put 0, -2 in, I have 2 times 0 plus 3 times -2, which is -6. So my minimum value is right here. So the minimum is at 0, -2, and this is the minimum value of the function. So that's just another scenario of how this works. And this is more of a challenge problem, and so you can go ahead and skip this one, and that makes for a nice short 3-4 lesson. Good luck with your homework.